Hello SGD, Sacred Geometry Decoded. I'm going to be adding this to the series in regard to understanding the Great Pyramid and the ancient sciences. I'm going to break this up because it's a little, well, basically it's about WTH. What's going on here? And this has all to do with science, measurable, testable, tangible elements that are represented in the Great Pyramid, including the vesica, for instance. But let's think about it. Now, what is the purpose of the pyramids? I cannot tell you. I don't have a time machine. However, through measurable, testable, tangible elements, I can say with very strong confidence that one of the most essential elements of a pyramid was about preserving the knowledge that we and our ancestors have communicated. That essentially the Great Pyramids, not just the Great Pyramid, but the pyramids as a whole, including even Luxor and Karnak, because they reflect the same geometry, math, astronomy, musical connections as well. That they are all joined to, essentially, they are a geometric, mathematical, and astronomical, and musical textbook, the quadrivium, which is so strongly connected through legend to Hermes Trismegistus. But what we have is these geometric, mathematical constants, and these are in this post-truth world. What we have is we do have certain truths, and they are universal geometric cosmic truths. And here's a list of them to begin with. Now, we also should include the vesica, the Lucas, and the Fibonacci numbers. Now, the concept is why? Okay. This is a hypothesis. I don't have a time machine, but let's begin. Let's imagine the designer, whether it's Thoth, Imhotep, Hermes, Nuar and Fuzi, all these ancient gods of science, knowledge, geometry, math, chemistry / alchemy, generally science in general. All our knowledge will be lost. Our greatest achievements will be gone with a flood or a fire or a rioting mob. This is, historically speaking, a fact. Whether it's the Library of Alexandria, other libraries, what happened to Hypatia, for instance. So even if our libraries escape these calamities, time will erode the records. The knowledge will be lost. By that I mean, if you were to write it down on papyrus, for instance, or parchment, it will rot away with time. Time will erode everything. Even there's a nice saying, even the pyramids fear time. Nothing is above time. Time will conquer everything. However, if you want it to last for maximum possible length of time, you wouldn't write a textbook in papyrus or parchment or even copper. You would write it in stone. Our scrolls and books will rot and crumble. This is known. Our language will even change over time. In one short generation, when I was a child, what certain words meant now and what they mean now has changed completely. Language changes over time. Meaning changes over time. There are certain constants, however, geometric, mathematical constants, which are universal. They are cosmic. They are eternal truths. And so our scrolls, our books will rot and crumble. We must make a new type of library. Rather than keeping the knowledge inside houses of stone, we will do something different. We will make our textbooks from the stone. From the very stone itself, the house of the library will be the library itself. The library building will be the very text itself, textbooks in stone. Geometry, universal constants, cannot be lost in translation. Geometry, textbooks in stone. Let's just call it sacred geometry. So whether it's the seed of life, fruit of life, and flower of life pattern, compass and straight edge geometry, these geometric are literally constants. They are universal truths. And so the pyramids, let's for the moment assume it's coincidental. Let's assume that for the moment. Because essentially that doesn't matter. What the really important fact is about the pyramids is that they represent textbooks in stone. Let's just say it's purely accidental for the moment. The fact is they still represent textbooks in stone of very sophisticated, truthful geometric mathematical knowledge. Textbooks in stone, the quadrivium, geometry, arithmetic, (mathematics), astronomy, and music theory. These are facts. These are facts repeated in the Great Pyramids. Not just the Great Pyramid, not just Khafre Pyramid, not just Menkaure Pyramid, but throughout the pyramids of Egypt. So we go back to 1859. John Taylor was the first to have published discussing the possibility of hidden geometric mathematical knowledge hidden in the Great Pyramid. His book, The Great Pyramid, Why Was It Built and Who Built It? Well, okay, let's assume it's coincidence, but this coincidence does lead us to universal mathematical geometric constants. For instance, the Great Pyramid itself. By simplified idealized measurements, we'll go into the details more, but it's 440 Egyptian royal cubits wide at the base and 280 Egyptian royal cubits high. This gives us pi and phi to a very, now this little squiggly equal sign means almost equal to. So what we have is phi and pi almost. We need to include other very important measurable details in there, and the almost becomes essentially perfection beyond any reasonable standard of margin of error in measurement. But this is John Taylor, 1859. This has gone, Schwaller de Lubitz was another one to investigate certain connections in there. This 7 high to 11 wide proportions. That's really what it is a triangle, 11 wide by 7 high. From this, so much information is encoded, cosmic, universal, truthful information. It's not subjective, it's objective truth. I'll put a link in the description to the CPAC Alan Green trailer. Very interesting. I'll be touching on this further because a good portion of this is based on the published work of Alan Green, and specifically this video, the CPAC Alan Green trailer. Sacred geometry. It's something to think about. Think about it a little bit more. Compass and straight edge geometry, circles, astronomy, architecture. These are the essence. It's encoded in the ancient text. This is beyond doubt. But let's begin with the pyramid itself. So I've just got the height, the slope, the corner, angle, the cross, and the diagonals. So all measurements I'll be showing here are based on an Egyptian raw cubit ERC, which is a pi over 6 meters or 0.5236 meters, one Egyptian raw cubit. 280 ERC high, 440 at the base, therefore half base is 220. Therefore the slope angle from the middle to the peak is 356.8987, etc. Therefore from the peak to the corner, or the corner angle, 418.568997 Egyptian raw cubits. We're using Pythagorean theorem to work that out. Therefore the diagonal is 622.2539. Therefore the half diagonal from the corner to the center is 311.1269.837. These are the idealized measurements of the Great Pyramid. We'll go into detail more, but we just start with the idealized measurements. So idealized measurements, however, if you look at the actual multiple surveys that have been done, whether it's J.H. Cole, Petrie, Dorner, up to the most recent period, what we find is that, for instance, let's begin with the southern base. The south side is the longest, and it is 756.072 or 0.084 feet, as where the northern side, the shorter side, is 755.428 or 755.425. There is a 20 centimeter difference between the longest edge, the southern edge of a Great Pyramid, and the shortest edge. Just with a measuring rod or a piece of rope, you even a dullard could do better just with a rope. This was intentional, and this imperfection in the measurement will actually lead us to perfection. But for the moment, we're working on the idea of idealized measurements, essentially 440 wide at the base and 280 Egyptian raw cubits high. These dimensions proportions will be used for the moment, and it'll actually lead us, the imperfections lead to perfections. There's also something else to consider, is that, for instance, the Great Pyramid has 8 sides. There is a slight indentation in the middle. So from corner to corner is one way to measure it, but it's also to measure it from corner to half base to corner. This will come into it later because these variations again lead to perfection. So we're going to have basically 99.95% accuracy, include the variations on the 8-sided pyramid, or the fact that no one side of a pyramid is exactly the same. Imperfection leads to perfection in this way. So let's begin. We have Menkaure Pyramid, Khafre and Khufu Pyramid, or the Great Pyramid. These are the three pyramids most famous. Giza Plateau, Red Pyramid, of the Bent Pyramid, of the Meidum Pyramid. The other of the, let's just call them the Great Pyramids. And we also have a smaller 1 meter high capstone, which was found next to the Red Pyramid, which shares the same 7 to 11 proportions of the Great Pyramid as well as the Meidum Pyramid. They all share this 7 to 11 proportion. The Great Pyramid, the capstone, 1 meter high, found next to the Red Pyramid, and the Meidum Pyramid, we know what the angles were because there is enough surviving of the base to confirm both the base length and the height because of the angle. These are linked. Now we need to look at the problems of antiquity. These are essentially Greek geometrical mathematical problems, which in the standard textbook will say were questions which were not even really raised, let alone attempts to answer them until the Greek period, some at least 2,000 years after the Old Kingdom. But what we have is Khufu, the Red Pyramid capstone, and the Meidum Pyramid are essentially answering one of these most important problems of antiquity, and that's squaring a circle. So here we see with the pyramid, if you draw a circle around it from the height and you make a square of the base, you're squaring the circle. 7 high to 11 wide, so therefore the edge length of the square is 11, and the radius of the circle is 7, which brings us to pi and phi, but it is a very, very good approximate of squaring the circle. That's to begin with. We've squared the circle. Okay, this is one of these problems. All of these will be lit up later. Okay, squaring a circle. The next one, problems of antiquity, will be doubling the cube. How do you double the volume of a cube? I can take a cube that is 1 foot long. I can therefore make the edge length 2 foot long. I've doubled the size, but I have not doubled the volume. This is a very important, tricky question. And doubling the cube, also known as the Delian problem, is another ancient Greek problem which should not have even been contemplated according to official history 2,000 years before the Greeks. And yet, another one of the problems, geometric problems of antiquity, which will link the Khufu pyramid and the Bent pyramid. Now, for instance, the Delian problem, or doubling the cube, is a problem about doubling the volume of a cube, for which you need to find out the cubed root of 2. Now, the sarcophagus in the upper chamber or king's chamber inside the Great Pyramid, if you were to fill it with water, now there's a corner missing, but let's say it was still intact as it was. If you were to, for instance, fill it with water, the volume of that water would be exactly or above 99.95% accurate, half of the volume of the sarcophagus itself. So if you take the measures of a sarcophagus, that gives you the external volume. You take the measurements inside the hole, and you have the internal volume, which is at a ratio of essentially double, 2 to 1. This is a Delian problem, and there is the answer there in the example of it in the Great Pyramid. The cubed root of 2, 1.259921, etc. That's what the number you're looking for. Well, the Bent Pyramid, so the base angle, slight variations in the Bent Pyramid, slight variations in all of the pyramids, but let's look at these angles. And, well, 1.258, 1.259, 1.258 equals 54.56666 divided by 43.6666. There we have the second very, 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 very close approximate of the Delian problem, or doubling the cube, some 2,000 years before the Greeks. Squaring a circle, doubling a cube, and constructing a heptagon. This is another one of the so-called problems of antiquity, another one of the problems which can be found in the Great Pyramid and the connected pyramids itself. So, constructing a heptagon, or a 7-sided polygon, or a 7-pointed star, either way. One of these problems associated with, not one of the classical problems, but one of the problems of antiquity. Now this will link the Great Pyramid, Khufu, or Cheops, the Red Pyramid capstone, as well as the Pyramid at Maidum. So I've now just tilted it a little bit, so let's just say, well, let's not say what it is. If you divide 360 degrees by 7, you get 51.42857, 142,857, 142,857 degrees. Technically speaking, with a compass and straight edge, you cannot solve squaring a circle, doubling a cube, or constructing a heptagon. You can only, because of the vagaries of pi, it's a transcendental number. But what we have is the Great Pyramid, or the Maidum Pyramid, or the capstone next to the Red Pyramid, is 51.84 degrees. That's 0.42 degrees off. Now, if you include the slight variations in there, again, what you have is an extremely good approximate. If you include the variations, we're approaching perfection. And of course, Great Pyramid, the capstone next to the Red Pyramid, 1 meter high, and the Maidum Pyramid are all in this 7:11 proportions. This very simple basic geometry actually leads to a whole set of information. If you look at the Great Pyramid individually, it encodes by coincidence or by design, and it is engineered. This is not a pile of earth built up by the wind. This was extremely engineered. It is the literal definition of engineered, man-made. That needs to be taken into account, because this now, if you include the other pyramids and how they combine through these geometric constants, the proof is very, very strong word, but to say it is pure coincidence, that's delusional. Like, I mean that literally. You have a mental health issue if you do not at least consider this, or if you just outright dismiss it as pure coincidence. I'm sorry, but at this point you need to see a doctor, because you're not well in the head. Okay, let's think about that. So, squaring the circle, doubling this cube, constructing a heptagon. Geometric problems associated with the Hellenistic Greeks, the later Greeks, who came at least 2,000 years after the pyramids. So we're talking about Pythagoras, just like Pythagorean theorem, a squared plus b squared equals c squared. Most official history will just refuse to accept the notion that this was known any time before Pythagoras. Some will say, some will observe always mathematical geometric universal constants in these engineered buildings, which link through mathematical geometric constants. And then there is the orthodox view, which is just, it's coincidence because I'm an Egyptologist who is illiterate or completely phobic of math and geometry. Again, it's extraordinary that this is not even considered, that people such as Zoe Hawass or Mr. Breyer insist that there was no maths in there. No, I can't prove it, but for them to suggest that there is nothing there is bordering on pathological. Sorry, that's just the truth. Now, Pythagorean theorem, a squared plus b squared equals c squared, which links us to Khafre's pyramid. I'll touch on this more. I did it in the previous episode. Just like the Delium problem is solved in the sarcophagus, or sorry, in the king's chamber or upper chamber, we also have the 3, 4, 5 triangle, Pythagorean theorem, which links to, well, the greats of astronomy, geometry, arithmetic, and music all refer back to certain geometrical, mathematical constants. These are universal truths, and, well, I put my trust in them. No, let me rephrase that. I don't put my trust in them. I put my trust in the incontrovertible truths of math and geometry. I don't really care for the individual. What I care for is universal, cosmic, essential, eternal, omnipotent truths. And here they are, reflected in the pyramids. Fibonacci numbers again, Lucas numbers connecting the 3, 4, 5 triangle, the 3 to 2, which is a musical, relates to Pythagorean tuning. But back to these constants, geometrical, mathematical, universal truths. So now let's look again, we'll be looking at the pyramid idealized measures. So for instance, that would be 440, that would be 622.1 something, but square root of 2. The base of the Great Pyramid is not perfectly square. The margin of error, the alleged errors in construction will lead to essential perfection. But let's begin with the square root of 2, and we'll use the idealized measures. We'll get into this more in future episodes. But by definition, the square root of 2 is there. Basically, the compass and the square, or square root of 2. Square root of 4 is too easy. That's 2. So that's also in there. The square root of 2 and the square root of 4 are very important, but we can just touch on them for the moment. And now let's go to pi. Pi is universal, is infinite, cosmic. It's a truth. It is so important. It is a constant. Cannot say that enough. It is one of the mysteries, but also one of the truths of the universe. And we find a very good approximate of pi in the idealized measures of a pyramid. Again, if you include a slight variations, essentially get perfection well above any reasonable standard of margin of error in measurement. And we'll look at that more. But just as it is using the idealized measures, we're above 99.96% accuracy. Whether it's volume of a sphere, working out the volume of a cylinder, area of a circle, or cones, these are just beautiful universal truths. Again, this doesn't matter where you live in the universe, they'll all come back to this. And now also Euler's identity, e to the I pi plus 1 equals 0. This is considered one of the most beautiful equations in maths, and this plus 1 or minus 1 is another constant that links so many proportions. Again, we'll get into this. Okay, pi over 6. Idealized measures, so we go from the peak to the corner and we include the socle or the paving stones. So the half base divided by that measurement, we get pi over 6. We'll go into this in more detail again, but we get a very good approximate just to begin with. That's the socle, the paving stones, 55 centimeters. This in itself encodes profound information, which links to meter, the foot, and the cubit, and so much else. But again, above 99.937, 93.994%. Like in any other field, this level of accuracy would not be dismissed. It would be, okay, we've got something here, we need to investigate. Now, pi over 6 will also relate to, okay, let's begin with a hexagon. Okay, let's look at a hexagon closer there. One of the beauties of a hexagon is that the radius of the circle is equal to the edge length of the hexagon. That's one of the reasons why it's beautiful. So the diameter, therefore we have a pi over 6 ratio. So the diameter, and then we have that section of arc, pi over 6. The ratio of a sphere inside a cube is pi over 6, and it just so happens that one Egyptian raw cubit, the defining measurement of the Old Kingdom, is pi over 6 meters. So this hexagon, one diameter to there is, well, it all links. Again, this is just the surface so far. We'll get into this more and get into the details, and it approaches perfection. Now we have 5, a golden number, the golden mean, the divine proportion, has so many names, just essential element of the universe, of nature. It is not man-made. It can be seen throughout nature. But we can also get the proportions there built into the pyramid itself, the essential 7-11 proportions. There we get there. That's perfect phi. That's what the pyramid idealized measures say. 99.96%. One of now also, just because of the way geometry works, so it's essentially the same math. But if we take the base area of a pyramid and we take the surface area of all 4 sides, so surface area divided by base area will bring us to exactly that same number there. That's just the way geometry works. So, and that's one of the beauties of phi, is that it works first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th dimension onto infinity. Again, same 99.96% above. One of the beauties of the golden number is that phi minus 1 equals 1 divided by phi. Again, we'll see these are the same essential proportions in there to a very 99.99%. Again, if we include the slight variations on each side, the 8-sided indentation, 99.99% becomes 99.999999%. This will be repeated forever. We'll do this in the future. Okay, one of the beauties about another beautiful thing about the golden number, phi plus 1 equals phi squared. If you include the subterranean to the height, gives us a 5:6 ratio. So again, same thing as we saw earlier with the golden number, or actually with pi. So this is, okay, let's not revise. The maximum visible base, 880 divided by the total height, including the subterranean, brings us to phi plus 1, 2.61904. Again, very close. 99.96% again. If we include slight variations, 99.999999%. Well above any acceptable margin of error. Square root of phi. So we take the height, we divide it by the half base, we get a very good approximate of the square root of phi, 99.94%. Again, include variations. We're going to get much better in this. Future episodes will go into that. In that same proportions, we get also a very good approximate of 4 divided by pi, 280 divided by 220, 1.272727, etc. Exactly the same. Now we get 99.96% accuracy of 4 over pi. Why is that important? The area of a circle, if that is 1 and the circle is inscribed inside a square, the ratio of area is 1 to 4 over pi. Universal geometric mathematical constants. It's incorporated in these ancient structures, beginning with the Great Pyramid. This is one pointed out, especially credit to Alan Green, Bard Code or Shakespearean equation channel, Broom's theorem. Yeah, we see we get 99.98%. This is important in the study of prime numbers, universal constants. It's also especially connected to twin prime numbers. So there are prime numbers that are next to each other with an even number in the middle. Now, for instance, 107 and 109 are twin prime numbers. 108 is in the middle. There's an Easter egg for you. But important study of prime numbers. The Euler-Mascheroni constant. So the maximum visible base, 880, divided by the diagonals and the height together. Again, Alan Green was the one who pointed this out. What do we get? 0.57723. Euler-Mascheroni constant. 99.97% accuracy. It's actually above that, but here it is. Include the slight variations in each side of a pyramid, 99.999999%. They knew what they were bloody doing. Okay, now this is connected to the harmonic series, or this is a screenshot from Wikipedia, natural logarithms. This will, if you noticed earlier, went from the square root of 2 to the square root of 4. Well, the inverse of the square root of 3 is 0.57735. Very close to the Euler-Mascheroni constant. Include the variations in each side of the pyramid. You get perfection once again, or well above. So square root of 3, it's related. It's just the Euler-Mascheroni constant inverse. 1.732395, etc. 1.73205. 99.98%. In any other field, this will just be accepted. The square root of 5, which connects to the golden number, phi. Square root of 5 plus 1 divided by 2 equals phi. We can also see that here. 99.98%, extraordinary. It also links to Lucas and Fibonacci numbers, because if you divide the Lucas by the Fibonacci, basically you come down to square root of 5. Lucas and Fibonacci numbers in themselves bring us to phi. Phi is based on the square root of 5, 1, plus square root of 5 divided by 2. Fibonacci numbers, Lucas numbers, golden ratio, square root of 5, all incorporates together the Lucas and Fibonacci's. Previous episode to this, how they link individually different pyramids, how they link collectively the great pyramids of Egypt. Mathematical geometric truths. Now, whether it was by accident, which is just taking reason, thought, and probability to a new level of delusion, at least not to consider the possibility. Again, even the most simplest probability at a very conservative level, we're looking at 1 to 1 0 0 0 0 0 0 0 0 against. It's at the very least a very compelling question. In any other field, this level of connection wouldn't even be considered pyramidal or the fringe. But yet, for some reason, these mathematical geometrical connections, measurable, tangible, because everything that is reflected in the geometry here is repeated through a specific set of measurements. What is repeated on the outside, what is on the outside is repeated on the inside. It's very as above, so below. As on the inside, as on the outside. As in proportion, as in dimensions, as in the literal number of the measurement will reflect the number of the proportion itself. Any other field, this would just be a no-brainer. Yet, for some reason, I can't explain. Okay, square root of 6 would be another example. Again, idealized measures. We'll get into that more in future episodes, looking at the slight variations. But even on the idealized, 99.98%. Again, any other aspect, all this is something of interest. Yet when it comes to the pyramids, highly engineered, constructed. These are not natural structures. Just like if a modern bridge or a modern building, you were to find these constants in them, there would be no question that the architect had deliberately tried to incorporate this knowledge into the structure. There are Wikipedia pages on mathematical architecture. There are books written on it. This is any other time, any other architect, any other building beyond dispute. Yet for some reason, when it comes to the pyramids, it's verboten. It's forbidden, it's taboo to even suggest these things. Measurable, tangible, repeatable, universal constants. Okay, Fibonacci sequence, which Fibonacci numbers related to the Lucas or especially the Fibonacci numbers. We find that again a very, very, very close approximate, 99.98% again. Reflected in the pyramids now, Euler's number, or E. So earlier we saw the phi card. Now if we divide the base by phi, we get, well, that's E. So we get E times 100, or a very, very close approximate of it. Now this is an important feature. Whether it's times 10, times 100, or times 1000 is another repeated constant throughout the pyramids in regards to their internals and their externals, their relationship to Heliopolis, to Alexandria, to Port Said. We'll be coming back to this. Times 10, times 100, times 1000, it again is a repeated aspect of it. If you look at the ancient Egyptian measuring systems, they were essentially working off base 10 units for a large part, because, for instance, a lot of pyramids are 100 Egyptian royal cubits at the base. We'll come back to this. Now let's look at E minus 1. Now back to Euler's identity and the minus 1 plus 1 thing. Phi plus 1 equals phi squared. Phi minus 1 equals 1 over phi. The square root of 153 is the number of full moons per year, or synodic months, 12.369. 12.369 plus 1 equals 13.369, which is the number of sidereal months per year, 27.3 plus 1. It's extraordinary. Again, if it was to appear in a modern structure, this would just, well, obviously he did that, or she, let's not be gender specific. Yet, for some reason, now whether it's Euler's number, pi, phi, this can be done essentially with the same instruments that the ancient Greeks had, that the ancient Egyptians had, and that in Western times, whether it was Euler or these, they did not have computers. They did their math the old-fashioned way, and they were able to come up with it. They were using ancient technology. Their time was a time of ancient technology, essentially, whether it was lifting equipment, chemistry. This had been essentially unchanged for thousands and thousands of years. Even medicine was still looking back towards the old model of the four humours, and we were still in the ancient world pretty much at the time of Euler and just before, and they were able to achieve these things with instruments and techniques that were essentially ancient. So why is there this pathology to say, well, there's nothing before Greece, that anything happened in ancient Egypt, mathematically, geometrically speaking, not to be considered? But if you look up the Parthenon, even amongst the mainstream view of things, I'll look at the math and I'll say, oh, well, this is obvious. It was Phidias, it was Pythagoras, of course they were doing this. Yet pyramids, no, there's a mental block there. But anyway, E minus 1. There's the proportions. Now what's important about E minus 1, there are 1.717 ... English feet per Egyptian raw cubit. Previously I mentioned pi over 6. There are pi over 6 meters per Egyptian raw cubit. Everything that is geometrically represented here will be repeated through measurement. We'll get into that in the future. And if you look at the actual measurements and you include the slight variations, all of this 99.93, 99.98, 98.95% becomes 99.9999% accuracy. It is measurable, it is testable. These are universal constants. Now, these last ones, okay, so all of this was essentially based on the 7 to 11 proportion. However, okay, we'll go through it the other way. So all of this E minus 1, pi over 6, 4 over pi, etc., based on the 7 to 11 proportions, even doubling the, well, not doubling the cube, but squaring the circle and constructing a heptagon. So all of these here on the outside are essentially related to the 7 to 11 proportion, but through the Lucas and Fibonacci numbers, through doubling the cube, through the seed of life vesica geometry, this will also link to Pythagorean theorem 2. It's just, it's extraordinary. And okay, so those are some screen. That's like Alan Green. Okay, that link will be in the description, but it's whether by design or by accident, for the moment, that doesn't matter. The fact of the matter, the geometrical, mathematical, and measurable fact of the matter is that even if it was by accident, the Great Pyramids encode profound, universal truths, geometric, mathematical, also astronomical and musical. So whether it's by accident or whether it's by design, it doesn't really matter. What does matter is that with measurable, testable certainty, there are these interesting series of connections, and there are those who basically occupy the throne room of the mainstream, who would even to suggest these questions is an act of heresy. That's not really being. I'm not exaggerating actually. There in there, you think whether you just look at whether it's for instance, someone commented Bob Breyer or Zoe Hawass or Mark Lerner. For that, they cannot even consider these possibilities. Actually, not even consider. They're violently opposed to them. Violently, I mean in not physical violence, of course, but you'll find this repeated throughout the establishment in regards to so many aspects. You can measure, test these, look up the sources for yourself. You can check this. I implore you to check this, actually. I double dare you to check it. What we have is profound knowledge, and even if it is accidental, even if this was not intentional, which is really, really, really stretch and reasoned for not to even consider it, but if it is by accident, at the very least, this is the most beautiful accident in human engineering ever. And by accidentally, they have left us textbooks of geometry, music, astronomy, and arithmetic. And why is this not being taught? Actually, the question is not even why is it not being taught. The question is, why are those who are given the power and the authority and the budgets and the airtime on the mainstream so against even considering it? And measure, and the truth shall set you free. What we have is, by beautiful symphony of coincidence, a series of beautiful universal truths, mathematical truths, that are unquestionable in themselves. Whether the design of a pyramid was designed to incorporate it, well, it is a highly engineered building. You don't just build a giant skyscraper high pyramid on a whim. It takes a lot of design, a lot of thought, a lot of preparation. And this needs to be, these are engineered. Bridges don't fall out of the sky. Bridges don't get made by particles of metal fusing across a river and creating a bridge. They're designed. It's an architect is involved in the construction of these things. And the architecture is clear, the geometry is clear, for math is very clear. And then if you incorporate the fact there are slight variations, again, this 99.997% becomes 99.9999999%. Any other equation, any other field, this will just be accepted. Yet, there you go. I've got to harp on it. Measured, testable, verifiable. It's sourced. And, well, it's math. It's not sexy. It's, So, who built it? I don't know. Doesn't really bother me. When was it built? I don't know. Doesn't really bother me. Everyone agrees it's at least 2,500 years old. At the very least, this shows that at the dawn of official history, official civilization, they had sophisticated math and geometry, which also links to astronomy and music, and something was going on there. Something just doesn't add up here. It is really like, what the F? Why is this not even on the radar? Why are those who do have the authority, who do have the power, who do have the sources, who have the funding, why are they so resistant to even considering the possibility of these things? Well, all I can say is the time is now. We live in this we live in the information age, which is ironically the post-fact world. We live in a world where mainstream organizations control and push a certain narrative. We also have the alternative narrative, which pushes down a very certain road. But the time we live in a cursed time, we live in a blessed time, and that the time is now to turn the information age into an information age rather than a disinformation age, rather than a political preconceived narrative. The time is now.